So today we're looking at probability. However, as you can imagine in statistics, there's a bunch of different styles of probability that we're going to come on to. This is specifically going to talk about generic probability and Venn diagrams. Now, both of those you should have covered in GCSE maths. However, of course, there are a few extra pieces. The generic probability is going to be virtually the same as GCSE maths, but the Venn diagrams have a couple of extra pieces added in. So we will go through them one by one, nice and slowly. But just so you're aware, this isn't the end-all be-all for probability. We have a bunch of distributions that we have to do as well. Now, let's get started. So we have the Venn diagram below shows three events, A, B, and C. And it says, write down two of the events that are mutually exclusive. So first of all, we should probably discuss what mutually exclusive means. So mutually exclusive simply means that they both cannot happen at the same time. So just put a box around here just so you have the definition. Cannot happen at the same time. At the same time. Okay, and that's really, really important. So what would that look like on a Venn diagram? Well, what it means is, if I just kind of describe what a Venn diagram shows you first, we have all of our events drawn as circles. Outside of the circles, but inside the rectangle, is, for example, in this case, it's the letter R, is the probability that none of these events happen. Okay? So here is the probability that no events happen. Okay. If there is an overlap, it means that both of those events happen at the same time. So the number here, 0.25, is the probability that just A happens. It's not the probability that A happens, it's the probability that only A happens, because there is a slight difference. This number in the middle, however, is an overlap between A and B. That is the probability that A and B both happen. So, for example, it could be something like flipping a coin and rolling a dice. A could be the probability when you roll a dice you get a 6. And B could be the probability that when you flip a coin you get a heads. So the probability of getting heads and a 6 in this case is 0.15. If there is no overlap, so if, for example, the circle A and the circle C do not overlap at all in this particular Venn diagram, then they can't happen together. A and C are mutually exclusive. So for an example of that is, again, let's go back to flipping a coin. A could be the probability you get a heads, and B and C could be a probability of getting tails. Now, of course, you can't get a heads and a tails at the same time. They are mutually exclusive. So that is an example of a mutually exclusive event. So the answer for part A, write down two of the events that are mutually exclusive. You just look for the two circles that do not overlap, which in this case are A and C. So hopefully that makes sense. Just as a recap, in the overlaps is the probability that both of these events happen. So in this case, 0.15 is the probability that A and B happen. All of the numbers inside A will add up to the probability that A happens. So the probability of A happening is 0.25 plus 0.15, which is, of course, 0.4. Okay? So the probability of A happening is 0.4 in this particular case. But the 0.25 is the probability that only A, nothing else happens. For the next part, it says events A and B are independent of each other, and the probability of getting C, which means in this case P plus Q, is equal to 0.3. So we have to find out the values of P, Q, and of course R as well. So what's the easiest thing to start with? It's definitely the part P. Okay? And what we're going to do is we're going to use this thing here. Events A and B are independent of one another. So what does it mean when two events are independent? Well, in words, it simply means that if two events are independent of each other, it means that one event occurring does not change the probability of the other event happening. So let's think of an example. Let's think of an example of two events that are independent. Again, let's go back to our normal kind of situation. Let's say I'm flipping a coin and I'm looking at the probability of getting heads, and I'm rolling a dice and it's a probability of getting a 6. Now, no matter what the outcome of flipping the coin, it will not change the probability of rolling a 6, right? They're independent. They don't affect one another. But what's an example of two dependent variables? Well, imagine this situation. What is the probability of me taking an umbrella to work? Well, that depends on the probability that it's going to rain that day. There you go. Those two events are linked. The higher the probability that it's going to rain, the higher the probability that I'm going to take an umbrella to work. Those two events are dependent, not independent. Whereas flipping a coin and rolling a dice, those two things are completely independent because the probabilities do not affect each other. One event happening does not change the outcome of the other event. So, what does that mean in terms of actual useful maths now? Well, if two events are independent, and this is a test that you can do, then that means the probability of A multiplied by the probability of B will equal the probability of A and B. Remember, this thing here just means and. So this is actually a test for if two events are independent or not. If you multiply their probabilities, it should give you the probability of the overlap. So what does this mean? Well, the probability of A, as we discussed, it's not 0.25, it's 0.25 add 0.15. So that is 0.4. And what about the probability of B? Well, the probability of B is going to be this plus this plus this. Remember all of the numbers inside the circle. So for now, I'm actually just going to leave it as probability of B. And that should equal the probability of A and B, which is simply just the overlap, 0.15. So now the probability of B is just going to be 0.15 over 0.4. And what this is going to do is give me what all three of these things should add up to, which is really useful because then I can work out what P is. So let's just whip out our calculators and do 0.15 divided by 0.4, which gives me 3/8, which is 0.375. So in other words, 0.1 plus 0.15 plus P So once again, we can use our calculators to just work out what P is. So it's going to be 0.375, so 0.375, subtract 0.15 and subtract 0.1. Whoops. Which is 1/8, which is 0.125. And that gives us what P is. Nice and easy. There you go. So we've already got some marks. Now, what about Q? Well, this one's actually a bit easier. They tell me that the probability of C, so i.e. P plus Q, should equal 0.3. And again, that comes from this line here. The probability of C is 0.3. So P plus Q is 0.3. But I know what P is 0.125. So Q is just equal to 0.3 minus P, which is equal to 0.3 minus 0.125, which should give you 0.175. Okay. So let's write it out one more time just to make it super clear. Again, for the examiner's sake or your teacher's sake, I would recommend just putting them in nice little boxes like so. Cool. Now what about R? Well, R is an interesting thing because there's one other fact about Venn diagrams we haven't quite mentioned yet. Inside this rectangle, everything should add up to 1. Why is that? Well, this box represents the entire possibility space. It is everything that can happen in this situation. Now, if the numbers didn't add up to 1, then that means there is a chance that something else happens other than nothing and these events. Basically what that means is you haven't included all the possibilities. Okay? So for example, if I'm rolling a dice and I include the numbers 1 to 5, it obviously won't add up to 1 because probability of getting 6 hasn't been included. So in short, every digit inside this should add up to 1. So let's see what it adds up to. So we have the 0.25 from over here, so 0.25 plus 0.15 plus 0.1, so I've just read these three numbers. P was 0.125 and Q was 0.175, and it adds up to 0.8. So R is just going to equal 1 minus 0.8, which is 0.2. So, like so. Hopefully that wasn't too new. I think the two things that were new were the mutually exclusive and the independent things. But other than that, it is a very typical but difficult GCSE Venn diagrams question. So here we have another Venn diagram because it is slightly different. It does look different to the other one. So it shows three events, A, B, and C, and again we have missing numbers, so you can probably imagine what we're going to be doing. But for part A it says, write down two of the events that are mutually exclusive, and there are actually two correct answers. If you remember, mutually exclusive means that they both cannot happen at the same time, and it's represented in a Venn diagram as having no overlap. So, which two circles don't have overlap? Well, A and C have no overlap, B and C also don't have overlap. So the correct answer is A and C, or you can put B and C. Don't put both, but one of those is completely fine. For part B, it says simply find the value of P, Q, and R. But if you have a look at the information they give us, they say the probability of A is 0.4 and the probability of A or B is 0.7. So let's start with that 0.4. So the probability of A being 0.4 means both of the numbers in this circle should add up to 0.4. So in other words, 0.2 plus P is 0.4. And you can probably already imagine what P is going to be then. 0.2. Nice and easy. But what about the other bit? Well, the probability of A or B happening is 0.7. So what does A or B look like on a Venn diagram? Well, I told you in the first part that A and B is the overlap. But what about A or B? A or B looks like this on the Venn diagram. So I'm going to use a highlighter. It's everything inside either one of these circles. Okay? So everything inside that figure of 8 looking thing. In other words, it's 0.2 plus P plus Q. So 0.2 plus P plus Q equals 0.7. And we already know that P is 0.2. So that's 0.4 plus Q equals 0.7. And that finally means that Q is equal to 0.3, just from subtracting 0.4 from both sides. So far, pretty good, right? 3 marks, and it's only been 2 minutes and 30 seconds. Not bad. And then it says, for the last part, state giving a reason whether or not the events A and B are statistically independent. And if you go back to part A, the first part, sorry, independent means that if you multiply the two probabilities of the events happening, it should give you the overlap. So let's try that out. We're going to do the probability of A multiplied by the probability of B and see if we get whatever P is. So we're going to see if we get 0.2. And I'm going to write that over there. So what's the probability of A? Well, keep in mind, it's not just 0.2. It's 0.2 and P. P is 0.2 as well, so in other words, it's 0.4. So 0.4 multiplied by, and what is B? Well, B is Q plus P, so it's going to be 0.2 plus 0.3, which is 0.5, right? Because both of those added together. And that gives me, that should give you 0.2 as well. So let me delete this. 0.2. So in other words, PA multiplied by PB does equal A and B. Therefore, they are independent. A neat little trick to kind of solve those types of questions. Now, this should give you warm, homely feelings from GCSE Maths, assuming that you did it somewhat recently anyway, because this is pretty much a GCSE Maths question. But we've learned how to use Venn diagrams, but now we should learn how to draw them ourselves. So we have Rahim asks 50 people which sport they watch. They can choose from football, golf, and hockey. And they give you just a boatload of information that, to be honest, doesn't make sense to a human being, right? It's very hard to kind of look at these numbers and understand exactly what's going on, which is exactly why we have Venn diagrams. So we have to draw a Venn diagram for this information. And if you notice, the first thing it says all 3 sports, and then there's also overlap between football, golf, hockey, between all the sports too. So what you want to do is draw 3 overlapping circles, which I always kind of struggle with, at least on paper, but thankfully computers kind of help me out here. So I'm going to draw your circles relatively large, or ovals in my case. So that way there is a big enough kind of consistency to it. So you can actually have a big overlap. So I like to draw mine pretty damn large. Them being the same size doesn't matter because it doesn't, we don't really care about kind of scale in terms of Venn diagrams. This is pretty reasonable, to be honest. This is actually not a bad one. And then please don't forget to draw the big box around the whole thing. And now what you want to do is label your circles. Now you don't need to write football, golf, and hockey. You can use letters. The examiners are relatively intelligent, and they'll be able to know what you mean, assuming you don't use some strange kind of notation for it. And you might notice something. In our previous Venn diagrams, we had decimals, right? Because they represented probabilities. But Venn diagrams can also be used to just represent whole numbers, because we can work out probabilities from whole numbers and proportions. So what do? I always start from the very middle, the overlap between all 3, and then I work my way out. So for example, it would be the overlap between all 3, then the overlap between any 2, and then the kind of just leftover ones, and then finally the number on the outside. Remember, there has to be a number on the outside. Even if it's 0, there still has to be a number, otherwise you'll lose a mark. So write something. It might be 0, it could be any other number, assuming it's positive anyway. Okay, but you need to put a number there. So, luckily in this case, they actually wrote them in order that we're going to be doing them in. Pretty useful. So 5 watch all 3 sports. There's no harm, no foul here. Just stick a 5 in the middle. Now with football and golf, it says 8 people. So you might be tempted to write this. The overlap between football and golf, 8. But this isn't quite correct. Because remember, it's saying 8 people watch football and golf. But there's 5 people that watch football, golf, and hockey. That includes people that watch football and golf, right? So you actually have to do 8 minus 5. There's 3 people that only watch football and golf. So just as a reminder, there is 8 people in total that watch football and golf, right? Because that includes the 5 people that watch all 3. Hopefully that makes sense. But there are 3 people that watch just football and golf. And you use that same logic with golf and hockey. So that is this one over here. 7 people watch golf and hockey. Well, 5 people are already accounted for. So that means there's 2 more people. Keep in mind that this number in the middle could be 0. So they might say 5 people watch all 3 sports and 5 people watch golf and hockey. You just write a 0 there. There should be no blank spaces. Always put the 0 if you need to. So I actually like to tick these off as I go along. So we've done these 3. Next we're doing football and hockey, and it says 9 people. So there's already 5 from here, which means there's going to be another 4 here. 31 people watch football. So what that means is everything inside the circle, which is F, so all of these ones, add up to 31. How many do I have already? I have 3, 7, 12. I have 12 already, and there's 31 people that watch football. So all we need to do is do 31 minus the ones you already have. So you could do, if you wanted to, just do 31 minus 4 plus 5 plus 3. Either way, you'll get the same answer of 19. And that goes in the football circle. Again, let's tick it off. 13 people watch golf. Well, how many do we have already? We have 3, 8, 10. 13 minus 10 is 3. So that's 3 people that only watch golf, no other sports. So let's tick that off. 17 watch hockey. Well, we have 4. Plus 5 is 9. Plus 2 is 11. So that means there's 6 more people that just watch hockey. Now, you might be tempted to leave it there because you have no other information. But we have more information. We have that there are 50 people that were asked. That is information. So what we want to do is add up all these numbers in the Venn diagram and see what we get. If we get 50, we'll put a 0 here. If we get 49, we'll put a 1 out here. Because those are people that don't watch football, golf, or hockey. So let's add all these numbers up and see what we get. 19 plus 3 plus 4 plus 5. Whoops. So that's football. Plus 3, 2, and 6 for the others. So it's 3 plus 2 plus 6. Gives me 42. I want 50, which means there are 8 people who decided they didn't watch any of those sports. Hopefully that makes some sense. For part B, it says that 2 people are selected at random. Find the probability that they both watch football. So what you want to do is work out how many people watch football in total. So that is going to be 19 plus 3 plus 5 plus 4. 31 people watch football in total. So I'm going to write that number 31 down. And how many people in total are there? There are 50 people in total. So there's a 31 in 50 chance of picking one person who likes to watch football. But we want to pick 2 people in a row. So you might be tempted to write the exact same thing again. But this isn't quite right because you can't pick the same person twice. Right? Should make sense. Let's say if I had a group of 5 people, so think of maybe members of your family. If I'm picking 2 of them, I can't pick the same person twice, right? Because those automatically get removed. So we actually subtract 1 from the total number of people, so it's now 49, and 1 from the number of people who like to watch football. That's your final answer. The reason why we times is because we're picking one person who likes football and another person who likes football. And when you say and in maths, it means times. So let's work out what that's going to be. Again, we can use a calculator, no harm, easy peasy lemon squeezy, over 49. 93 over 245, which is indeed the correct answer. Perfect. So 5 marks in total. Not bad. Now, the way it works for drawing Venn diagrams in terms of marking is a bit interesting. You actually start off with 3 marks. That sounds pretty good, right? However, you lose a mark for every number that is either missing or incorrect. So you start at 3, and if you miss out 2 numbers, let's say you miss out the number on the outside, that's 2 marks now. And let's say you get another one wrong, that's 1 mark. So effectively you get 3 mistakes. Okay? So just keep that in mind when you're doing Venn diagram questions. So we're going to go through some kind of rapid fire questions on drawing basically Venn diagrams and how these different things will look based on Venn diagrams. So a bunch of different scenarios. So pretty quick questions, but it's a nice change of pace from the fairly long ones we've been doing up till now. So for part A, again, 2 events are independent. Probability of A is at 0.4 and B is 0.3. Find the probability of A and B. Well, if they're independent, then the probability of A times the probability of B will equal the probability of A and B. So simply put, all we need to do is multiply them. So 0.4 times 0.3, which you can use a calculator, but it is just 0.12. And then it says just draw a Venn diagram to show this information. So once again, you're going to have 2 events, so we only have 2 circles this time. Makes it slightly easier for people who are incapable of drawing, like me. Good lord, that's disgusting. And put a box around it, of course. And label it A and B, so don't forget the labels, don't forget the box, of course. And then the probability of A is 0.4, but if you remember, the probability of both was 0.12. So I've kind of made that a bit small, 0.12. 0.4 minus 0.12 gives me 0.28. Because remember, we still have to have numbers inside the circles themselves. And 0.3 minus 0.12 would be 0.18. So now we have those three numbers. And are we done? No, we need to have a number outside the bracket, remember? So what do? Well, they need to add up to 1 in this case because it's probability. So we're going to do 1 minus, then all of these numbers, 0.28 minus 0.12 minus 0.18. And that gives us 0.42, which should go outside of both of the circles. So please remember to label the circles and also to have a number outside both circles but inside the rectangle. Don't draw it outside the rectangle either. So another rapid fire question. So two events A and B are mutually exclusive. Probability of A is 0.4 and B is 0.3. So write down the probability of A and B. Well, that is going to be 0. Why? Because they're mutually exclusive. That literally means that they can't both happen. So the probability of A and B happening is 0. Okay, perfect. So again, it could be something like flipping a coin and getting heads and tails. That's not possible. So drawing a Venn diagram for this information. So what's that going to look like? Well, it's going to look slightly different. It's going to look like B and C do here. There should be no overlap. So we're going to draw two circles and we're going to draw them separate from one another. A and B. We're going to draw a big old rectangle around them. Perfect. And what was the probability of A? It was 0.4. And B was 0.3. And once again, we need a number outside of both of the circles. So 1 minus 0.4 minus 0.3 gives me 0.3. And that's the number that's outside. Okay, nice and easy, nice and quick, I hope. One more rapid fire question and then we're moving on to two of the hardest exam questions that I've found. Keep in mind, and this is something I haven't mentioned in the previous videos, which I probably should have, just for those of you wondering, because I did get a few questions, are they all of the past paper questions? These are not all the past paper questions because, and for a very good reason, is at the end of the course, at least the AS stuff, I'm going to do all of the AS past papers. And at the end of the A2 course, I'm going to go through all of the A2, well, the overall A-level past papers. So I don't want to end up doing all of those questions before we actually get on to doing the past papers. So I take a selection of some of the really hard ones, and then I'm going to go through the whole paper slightly later on. And that way we actually have some practice exam papers to do, as opposed to just having the exam questions already done for us. So let's go through this. So it gives me probability of A, B, and the probability of A and B. Draw a Venn diagram. So all we need is two overlapping circles. This time I'm going to make the overlap a lot bigger. Call that A, call that B. Start from the middle like we did in the previous questions. So 0.4. Probability of A is 0.6. So 0.6 minus 0.4 gives me 0.2. And 0.5 minus 0.4 gives me 0.1. Don't forget the big old rectangle because that means we'll have a number on the outside of both circles. And how do we find it out? We add these up. 0.2 plus 0.4 is 0.6 plus 0.1 is 0.7. So 1 minus 0.7 gives me 0.3. And that's it for the rapid fire questions. Let's get on to some pretty dang hard past paper questions. This was actually a really tricky question for a lot of students. So if we look here, it says two bags A and B each contain balls which are either red, yellow or green. A contains 4 red, 3 yellow and N green. And B contains 5 red, 3 yellow and 1 green. Ball is selected at random from bag A and placed into B. And then a ball is selected from bag B and placed into bag A. And it says the probability that bag A now contains an equal number of red, yellow and green balls is P. Given that P is greater than 0, so essentially given that this is actually possible, find the possible values of N and P. So, let's go through it. First things first, it says the possible values of N and P. Now we can't really work out P without knowing what N is. So let's write down all of the cases for N and let's have a think. So essentially, we're going to take one bag from A and add one of any colour to A. Okay? How can we make them all the same? Well, what we could do, because the number of reds is bigger than the number of yellows, we could take one red and then replace it with something. Now, we don't want to replace it with a yellow, because then we'd have 4 yellows and 3 reds. So we could add one to the green. that will only work if n is equal to 2. So that's one possible case, right? Because if n equals 2, we take a red, that makes it 3 reds, and we add a green, which will make them all the same color. Okay? So in other words, we take a red from an A, so red from A, and green from B. That is one possible case. Let's work out the probability of that happening. What's the probability of taking a red from A if we have 2 green balls? Well, how many red balls are there? There are 4. And how many are there in total? So 4 plus 3 is 7, plus 2 is 9. Cool. Now, if we take this red ball and add it to bag B, we now have 6 red balls, right? So, how many green balls do we have? We have 1. And how many balls do we have in total? We have 6 plus 3 is 9 plus 1 is 10. So that gives me 4 over 90, which is the same as 2 over 45. So that's one value of P. So what's another value? Well, let's think of another use case. What we could do is make yellow into red. And what I mean by that is make all of the values equal to 4. So if you've noticed, what I'm doing is I'm looking at the numbers that I actually have and I'm making them the same as each other. So in the first case, I made the 4 into 3 by taking 1 away from the red. In this case, I'm going to make the 3 into 4 by adding 1 to yellow. And the only way we can do that is by taking 1 away from green. And we want the number of green balls to end up as 4 as well to make all 3 numbers the same. Which means green has to start off as 5. Because 5 minus 1 would give me the 4 that I need. So we have, what's the probability? So we're taking 1 green from A. Green from A. And we're going to take a yellow from B. So what's the probability of taking a green from A? Well, we have 5 green balls in this case. So it's going to be 5. Out of how many? Well, it's going to be 5 plus 3 is 8 plus 4 is 12. So 5 over 12. Multiplied by, so again we've added 1 to this green ball here, so we have 2 now. We're taking a yellow, so let's do 3. Over 5 plus 3 is 8 plus 2 is 10. So 5 times 3 is 15 over 120. We could divide them both by 3. We could also divide them both by 15, actually, which gives me 1 over 8. And that is my second set of values. That is 5 marks, which I think is very generous. However, of course, as you can see why this was a tricky question. It was a tricky question because you have to imagine these different scenarios. And the best kind of advice I can give you is A, practice as many questions as possible so you become familiar with it. But B, understand what probability is. Okay, it says here that there are an equal number of red, yellow and green balls. So we need to make these numbers the same. But how can we do that? Well, we're lucky because the green balls we can change. So realistically, this question is actually asking us, how can I make the red and yellow balls the same? Because, like I said, the green balls we change. So I can write that the green balls can be any number of balls. So I can ignore the green balls at the beginning. I want to make the number of red and yellows the same. How can I do that? Well, I can take 1 away from the red, or I can add 1 to the yellow. And then I can work out what the number of green balls is. So hopefully that makes a bit more sense.